Okay, this video is going to discuss some suggestions to help you enhance your report. I'll divide it up into three separate videos. Each one will deal with the laboratory in general that you may write up. So as an example, for 1.3, we'll talk about general things and then specific things. And we'll do the same thing for 8.4 and 2.1 in separate videos. Remember, these are just suggestions to help guide you. There are things you should likely consider when writing your lab report. They are not an exclusive list by any means, nor are they things that are mandatory, but they are suggestions for you to consider, and I would certainly expect for you to go outside the realm of things that I discuss here. And these are things basically, if we had that laboratory free-for-all, or that we would do in a laboratory free-for-all, where we would discuss the individual ones. So this one's on 1.3. In general, here are some things to consider. Double check JLR 13 and make sure you have covered all the points. Make sure you can check off each one on that checklist and then appropriately get it done. Look at the common errors that I've posted and make sure that you have avoided them. For 1.3, one of the big things you want to answer is, what is homeostasis? You should discuss probably how is homeostasis controlled, both intrinsically and extrinsically. Extrinsically, it's controlled by the ANS, hormones, and other things. You should talk about negative feedback and its role in terms of homeostasis, and likely, maybe even potentially work in Cannon's postulates as well. And again, that's not everything, but that's a nice list to look at, and nor do you have to do all of that as well. You get to choose in terms of what you want to do. Okay, so we'll look at the water bath portion first. Again, since this is in FOX 1.3a, then check that out, obviously. It would not be a bad idea to talk about how the water bath works, why the water bath is not a good example of homeostasis, maybe discuss what the positive points of the water bath are and then why they're not. Certainly in your discussion, you'd want to talk about negative feedback and antagonistic control. You should also maybe theorize what happens if you added boiling water to the water bath. That could even be as an example of a future research idea. So if you were to redesign the lab, what could you do to look at that? You probably, at some point in time, talk about control systems. What wouldn't be a bad idea is a comparison with a homeostatically regulated variable in the human body. So as an example, I think one of the most obvious ones would be body temperature, because that's homeostatically regulated, and maybe compare the water bath to homeostatically regulated variable in the human body, like body temperature. For your data, I would consider multiple tables or figures. I would have at least one for the 5 temperature measurements that we had in terms of the water bath. So remember, once it came up to what we call the set point, I should have included that, right? So don't forget set point in terms of this list. So you should certainly talk about set point and those numbers and how they relate to set point. So that would be something to look at. Those 5 measurements, the average of those we determined to be the set point. So that's something to think about. The other one would be the change in temperature over time. So once you dumped in the cold water, what happened to the temperature, and then how long did it take to go back up? This especially this last one, many people like to present it in a figure, so as a graph. Remember, since graphs, if it's not a table, if it's not rows and columns of things, it needs to be a figure. If presented as a figure, it's easier to plot the actual figure on a computer and then draw it in by hand. It's very frustrating on a computer, especially the word program, to try to get it to do what you want. So my suggestion is make the grid and then draw the trend line by hand direct on the paper is probably the easiest way to go. So those are some things to think about in terms of the water bath. Now, if you did the other part, 1.3b, right, the heart rate stuff, so you would check the Fox background on that. You should check out the lecture notes from the cardiovascular control for mean arterial pressure. So probably should have put that in. That would be S3P2. So S3P2 would go there. Also, check out the laboratory for 1314 for the parasympathetic and sympathetic influence on heart rate, right? So remember, we talked about the parasympathetic being most dominant at rest under 100 and sympathetic being more dominant at exercise when heart rate's above 120. So that wouldn't be a bad thing to look at. You should probably discuss what factors can influence resting heart rate. The factors would be, not exclusive, but when you look at the different things, would be the inherent rate of the SA node, how genetics plays a role, the gender, whether you're male or female, how body size influences it, maybe the parasympathetic tone. If you have a high parasympathetic tone, your heart will be slower. The level of circulating hormones, if you have a lot of epinephrine as an example, that would play a role. And certainly to a large extent what this lab is about, what level of fitness and how that is going to affect heart rate for individuals as well. So those are just examples of things that you could do. You should probably discuss the measurement of individual resting heart rate and how we got an average and took multiple ones to get a better idea of what's going on. You certainly should have a comparison of class averages for the two groups, so the exercise group and the non-exercise group, and that data presented somehow, and certainly a mean. You should discuss how heart rate's not homeostatically controlled. You should talk about the role of the ANS and hormones in determining heart rate, which we sort of looked at up there. You should discuss, even though heart rate's not controlled homeostatically, it's used as a variable to help control mean arterial pressure. What determines blood pressure, mean arterial pressure, is heart rate times stroke volume times TPR, so total peripheral resistance. So this variable, if we need to increase blood pressure, heart rate would go up. You should talk a little about stroke volume, because that's what really changes as you become a better trained individual. You have a higher stroke volume, which means your heart rate is going to go slower to compensate for that bigger stroke volume, because you need the same cardiac output. Right? So you should mention how the basic need for cardiac output between trained and untrained individuals doesn't change. How you calculate cardiac output, probably should mention heart rate and stroke volume. And then when you present your data, you should consider using separate tables or figures again, at least one for the heart rate measurements, so those individual heart rate measurements that you have for yourself or someone else in the lab, and then the class data of resting heart rates based on exercise and non-exercise. So those are the things you'd probably want to look at when looking at Fox 1.3, which deals with heart rate and the water bath.